Good morning, students. Today we are going to learn about hydrogen and its isotopes. Hydrogen is the first element present in the periodic table, and symbol of hydrogen is H. Its atomic number 1 and mass number 1. You all know it has one proton and one electron. And then this hydrogen is present in most of the compounds which we have come across in our daily life, that is water, the formula H2O where two hydrogen is there. Carbohydrate, that's compound of carbon and hydrogen and oxygen. Example glucose, fructose, sucrose, etc. So here glucose formula is given, that C6H12O6. So where hydrogen is present. And then protein. So protein, its general formula is NH2CHRCOOH. So you can find that is nothing but this protein is the combination of amino acids. When n number of amino acids contains to give you the protein. So amino group is NH2 where there are hydrogen, as well as acid group where there is hydrogen, and there is CHH. The simplest element, that is simple molecule of this protein is said to be, this R can be replaced by hydrogen. When you go higher, this R could be methyl, ethyl, propyl, etc. So even the methyl has hydrogen. Okay, so this is an example of this hydrogen compound. Then it has only one electron. Okay, so it's highly reactive. It wanted to attain a stable configuration, so it react with one more element. So due to its high reactivity, it always exists as a H2 in its elementary state. Okay, but it is present very small in the Earth atmosphere. The amount is its abundance is very small in the Earth atmosphere. Let's learn the position of hydrogen in the periodic table. It resembles alkali metals as well as the halogen of 17 group. So in some periodic table they used to keep the hydrogen above this alkali metal, some in the middle of the periodic table. So let's find where to keep this hydrogen in the periodic table and what are the similarities of hydrogen with the alkali metal as well as with the halogen. So the first we are going to see about how hydrogen behaves like alkali metals. You know that hydrogen form a unipositive ion, that is called to be H+. Like alkali metals, sodium, potassium, rubidium, cesium, all those can form Na+, K+, and Cs+. Likewise, hydrogen combined with halogen form hydrogen halide, and with oxygen oxides, peroxides, and sulfides. Like alkali metal can also form halide, sodium oxide, the sodium peroxide, and sodium sulfide. Then it can act as a reducing agent, like hydrogen can act as a very good reducing agent like alkali metals, but there is some deviation because the ionization energy alkali metals are very less. It is ready to lose its electron because its electronic configuration is 1 at the outermost orbital. Hydrogen has 1s1. Likewise, the other metal of alkali has ns1 configuration. It is ever ready to lose its electron. So its ionization energy is 377 to 520 kilojoule per mole. Okay, for alkali metals it ranges between these two, but when we measure the ionization energy of hydrogen, its ionization energy is very high, comparatively very much higher, that is 1314 kilojoule per mole. So here there is a deviation. So let's find where this hydrogen can be placed in the periodic table. Let's see how it resembles with the halogen group. So you know that like halide, that is halogen X, okay, it has a tendency to accept the electron. So it will release much energy to accept the electron. That is X can convert it into X minus. X is nothing but halogen, either fluorine, chlorine, bromine, iodine or bromine, okay. Fluorine, chlorine, bromine or iodine, it get converted easily into X minus by giving much energy. It attain the electron and it become X minus. So likewise, hydrogen also form a hydride ion. This hydrogen also have a tendency to accept the electron. But the energy difference between these two, what is accepting electron, that is called to be electron affinity. So the electron affinity is defined as the amount of energy released when an isolated gaseous atom accepts an electron. And when the energy is released sense, it should be negative because exothermic, much amount of energy is released. This bromine wanted to be bromide ion. To obtain the electron, it gives its maximum energy to gain this one more electron. So when it gains the electron, its energy is said to be minus 55 kilocalories per mole. But same way we said hydrogen also have the tendency to accept the electron and get converted into the respective gas called to be noble gas, that is a stable configuration. But when it accepts the electron, instead of releasing energy, we have to supply some energy, okay, plus 36, that is endothermic, heat is absorbed. Here it gives its maximum energy, heat is released, but here it is absorbed. So when you compare the energy for attaining the electron, for this hydrogen it is a very less amount of energy, there is very less amount of effort it put to get the electron. So the electron affinity of this hydrogen is said to be very low as compared to the noble gases, compared to this halogen. So then after this electron affinity, this is one property. The other one, when we compare about hydrogen, hydrogen always have a tendency to exist in the +1 oxidation, most of the compounds. So it gives preference to having the +1 oxidation state. So you know only the alkali metals will have the +1 oxidation state. So when we comparing both the property, that whether to keep it under alkali metal or with the halogen, they had concluded most of the properties as resembles to the alkali metal. So it is reasonable to place the hydrogen in the group 1 along with the alkali metal than with the halogen. So in the modern periodic table, by following the rule of IUPAC, now the hydrogen is placed along with the alkali metals. Isotopes of hydrogen. Hydrogen has 3 naturally occurring isotopes, that are protium, deuterium and tritium. Protium is the predominant one because it is 99.98% present, and the protium is represented as 1H1, where it has 1 proton and 1 electron, and there is no neutron. But deuterium can be represented as 1D2 or 1H2. 1D2 since it has 1 electron and 1 proton and 1 neutron. You can look at here atomic number, hydrogen, protium 1, mass number 1, so 1 proton, 1 no neutron and 1 electron. And deuterium you can see 1H2. So in all the 3 cases like protium, deuterium and tritium, the atomic number is 1, so the number of electron is 1. And the mass number is for protium 1 and deuterium 2, tritium 3. And here the mass number, as the atomic number is 1, the proton is also 1. But the from the mass number you can get the number of neutron. Mass number minus atomic number give you the number of neutron. For protium 1 minus 1 it is 0. Deuterium 2 minus 1, 1. So the neutron present in deuterium is 1 and the neutron present in tritium is said to be 2. So look at here, no neutron in the first case, 1 neutron, and tritium there are 2 neutron. The percentage abundance is deuterium 0.015 percentage and tritium very trace amount. So it was somewhat approximately 10 power minus 15. So or 1 atom per 10 power 18 hydrogen atom. Okay, 10 power 18 protium atom. So that is the amount of tritium present. So these 3 isotopes are occur naturally, exist as H2 or HD, because you know hydrogen can exist in the state of H2 diatomic state, or it can exist as HD because hydrogen, protium and deuterium together HD. Another one D2, that is deuterium exists as D2. Another form HT, protium and trace amount of tritium, that HT or T2, tritium and T2. So H2, D2, T2. Then H-D combining protium and deuterium. Another one combining protium and tritium, H-T. Another one combining deuterium and tritium, that is DT. So these are the ways it can exist in naturally. Let us learn the properties of, that is the comparative properties of protium, deuterium and tritium. So here the symbol for protium hydrogen, deuterium D and tritium T. The atomic mass of hydrogen is 1 and deuterium 2 and tritium 3. And number of electron, in all the cases it is number of electron, number of proton and neutron. That order it is given, number of electron 1, number of proton 1 in all the three. But the neutron alone, for the hydrogen it is 0, for deuterium 1 and tritium it is 2. And the nuclear stability, this is stable, hydrogen is stable isotope, and then the deuterium can also be stable, but only the abundance is little less. And this is radioactive because it can disintegrate, that is T half, that is nothing but the half-life period. Half-life period is nothing but the time required to disintegrate or disappear half of the radioactive substance from its initial concentration. If you take 100, from 100 to 50 to disappear, we take 12.3 years. That is what called to be T half. So T half of this tritium is 12.3 years. Molecular hydrogen. So this H will not exist as H in the nature. It can exist as H2. D can exist as D2. T can exist as T2. Then its abundance, already we saw that maximum is hydrogen, protium. Its percentage is 99.98 percentage. Deuterium 0.015 percentage. This is approximately 10 power minus 16. Molecular mass. Molecular mass means H2. What is it? Molecular mass. Atomic mass 1. So 2 into 1 it is 2. 008, that is 0.016, and this is deuterium. It's mass number 2.014. Multiply this into 2, you will get 4.028. This can be 3.016 into 2, you will get 6.032. Then the melting point in Kelvin. So hydrogen, it is 13.96 degree, 18.7 not degree, 96 Kelvin. 18.73 Kelvin, this is 20.62 Kelvin. So the melting point increases from hydrogen to tritium. Boiling point also given in Kelvin. Here this is 20.30, 23.67, 25. This also increases from protium to tritium. The next is internuclear distance from H to H. In hydrogen molecule, what is the internuclear distance? That is 74.14 picometer. The unit is given in picometer. This is also, so internuclear distance in hydrogen molecule, deuterium molecule and tritium molecule is said to be the same, 74.14 picometer. Next, about the critical temperature. The critical temperature is nothing but the temperature at which this hydrogen can convert it into a liquid state. The gaseous hydrogen can convert it into the liquid state. That is called to be the critical temperature. So this is the temperature at which H2 can convert it into liquid hydrogen. That is 39.19 degree 9 Kelvin. So temperature unit is Kelvin here. This is 38.35. This is 40. So this critical temperature also increases. So we can liquefy hydrogen comparatively faster than the other two isotope. Then enthalpy of dissociation. Enthalpy of dissociation is nothing but the heat energy at constant temperature and pressure. That is called to be enthalpy. So here the amount enthalpy of dissociation, the energy required to dissociate H bond H. The bond, how much energy required to break the bond between hydrogen and hydrogen. That is called to be the enthalpy of dissociation, where it is 435, this is 443, this is 446. 35 and it increases 43 and again it increases 46. So this also getting increases. Only the internuclear distance is constant, all other else are increases from hydrogen to tritium. This is the properties of hydrogen, deuterium and tritium molecule. In an atom, you have nucleus at the center and the electrons will be revolving around the nucleus. That's what called to be an atom. So where electrons are revolving around the nucleus as well as its spin in its own axis. Likewise, the nucleus will also have a spin, okay. So based on the nucleus spin, we have ortho and para hydrogen. So for that I am going to take a hydrogen molecule. So this is H and H hydrogen molecule. Based on the spinning of the nucleus in the hydrogen molecule, it can be divided into ortho and para hydrogen. So let's see what is ortho hydrogen and what is para hydrogen. When the spin of two hydrogen nuclei can be in the same direction. Look at here, this is ortho hydrogen where the nucleus is spinning in the same direction, in the clockwise direction, or both are spinning at the anti-clockwise direction. So look at here, here the nucleus are spinning at the same direction. When it spin at the same direction, when both the nucleus of hydrogen molecules spin at the same direction, then we can call it as a ortho hydrogen. But look at here, one is spinning clockwise direction, the other one is spinning to the anti-clockwise direction. So if it spin in the opposite direction, then we can call it as a para hydrogen. So let's see its abundant. So at room temperature, normal in the room temperature we will have 75% of ortho hydrogen and only 25% of para hydrogen. So from this itself we can conclude that which form is most stable. You know that ortho form is more stable than the para form. Then how to convert this ortho into para form? So only at room temperature 75% ortho will be present, but when the temperature is lower than the room temperature, when it goes lower and lower, the ortho form will be getting converted into the para form. But there is next one, how to convert back this para form into ortho form. Conversion of para hydrogen into the ortho hydrogen. So that can be done by some four method given. One is by using the catalyst platinum or iron. When para form is heated in the presence of a platinum or iron. Another one, passing electric discharge. To that para hydrogen, when you pass electric discharge, it can get converted into ortho hydrogen. Next, when you heat the para hydrogen above 800 degrees Celsius. So when you heat it above 800 degrees Celsius, it get converted back to ortho hydrogen. Then mixing with the paramagnetic molecules such as O2, NO, NO2 or with nascent or atomic hydrogen. With the para hydrogen, when you have to mix with oxygen gas or NO or NO2, these are the paramagnetic molecule. What is paramagnetic molecule? The molecule which containing unpaired electron. That the electron does not involve for the pairing. At least one unpair of electron should present. Then those molecules are called to be paramagnetic substance and can be attracted by the magnet. So when you mix this with the para form, it can get converted into the ortho form. This ortho and para hydrogens have the similar chemical properties, but it differs in some of the physical properties. So let's see what are the difference in physical properties of ortho and para hydrogen. Especially it was highlighted the melting point. Ortho hydrogen having the melting point of 13.95 Kelvin, but the para hydrogen 13.83. So ortho have higher melting point. Then the boiling point of ortho hydrogen is 20.39. This is 20.26. So the boiling point also for the ortho hydrogen is higher compared to para hydrogen. Then the magnetic moment is twice that of proton, because both the nuclei in ortho hydrogen are spin at the same direction. So both are spinning at the clockwise direction. If the clockwise direction spin, if you are taking as plus half and plus half, it is 1. So it is twice than that of the proton. Proton means only one. So only one spin, that is plus half. But here twice that spinning. One in clockwise, the other also in clockwise. One in anti-clockwise, the other also in the anti-clockwise. So that is called to be the twice that of the proton. But here the magnetic moment is 0. one spins at the clockwise, the other spins at the anti-clockwise. So the spinning of clockwise direction can be cancelled by the anti-clockwise direction, or the plus of one, another one minus of. So its magnetic moment is said to be 0. Let's learn the preparation of hydrogen. There are many methods to prepare this hydrogen. Out of that, the one is electrolysis of water. By this process, high purity of hydrogen can be obtained, that is greater than 99.9%, that is almost equal to 100%. So that much purity of hydrogen can be obtained by the process called to be the electrolysis of water. Let's see how this electrolysis carried out. For doing electrolysis, there are three things required. One is called to be anode, that is the electrode. One is anode, another one cathode, another one is electrolyte. So anode, here we are taking nickel as an anode. The anode sign is positive and cathode sign is negative. So here cathode, iron rod is taken as a cathode. Iron rod is taken as a cathode. And the electrolyte is nothing but the solution. What are we taking inside the container? That's nothing but aqueous solution of NaOH or KOH. That is with water, little amount of sodium hydroxide or potassium hydroxide is added. So that is aqueous means water, okay. Aqueous solution of NaOH or KOH is taken. And when these two are connected and when current is passed, the substance which you are taken inside the container, the electrolyte, undergo dissociation. So the main thing is the water molecule, it ionizes to give you H plus and OH minus. Water ionizes to give you H plus and OH minus. You know that opposite charge will be moving towards the, that is positive charge move towards the negative and negative charge move towards the positive. So here water ionized to H plus and OH minus. H plus will move towards minus and OH minus move towards the positive. And one more concept, at anode oxidation taken place, okay. At anode oxidation takes place. So this is anode where there is oxidation takes place. What is oxidation? Oxidation is nothing but loss of electron. In terms of electron, that's nothing but the loss of electron. So the OH minus goes near the anode, and this is OH minus, it get converted into water and oxygen. That 2 OH minus get converted into the water molecule again, plus the oxygen gas is getting liberated at anode. So at anode oxygen is liberated. And what is oxidation? Loss of electrons. So 2 electrons are lost because 2 OH minus, 2 minus charge, that is 2 electron is released. At cathode, if at anode oxidation takes place, means at cathode the reduction takes place. So at cathode H plus is attracted at cathode, that is H plus. This H plus gains these 2 electrons. The 2 electron lost by the anode will be gained by 2H plus and get converted into H2. So H2 gas will be liberated at the cathode. In our textbook we have, instead of H plus, we have there is 2 H2O. So that H2O can ionize into H plus and OH minus, and that H plus and 2H plus will be coming. That 2H plus will go as H2 and 2OH minus, that will be released out. And these 2H plus, plus means there is less electron, that will gains 2 electron. 2H plus plus 2 electron converted into H2. So at anode oxygen is liberated, at cathode hydrogen is liberated. So the hydrogen which you are getting will be 99.9% purity. The overall reaction is nothing but when you take water, it ionizes, undergo oxidation and reduction, at last oxygen and hydrogen gas is getting liberated. So we will be separating hydrogen gas from that. So here this process is not economical for large scale production. So we will proceed towards the other method of preparation of hydrogen. Another method of preparation of hydrogen is, that is laboratory method. In this method, metal when treated with dilute acid, it get converted into the respective salt and hydrogen gas is liberated. So either zinc, iron or tin. But here we have taken with the zinc granules with hydrochloric acid, it get converted into zinc chloride salt as well as hydrogen gas is liberated. So here you have an apparatus, in that zinc is taken at the bottom, and from the thistle funnel they will pass this dilute hydrochloric acid, and this HCl react with the zinc and it get converted into the gas, that is hydrogen gas. That's hydrogen gas will be collected here. So you can prepare hydrogen. Another method is industrial production. In this method, large scale of hydrogen is produced using a steam. Okay. So here, when steam is passed over the hydrocarbon, that is the methane, at the temperature of 800 to 900 degrees Celsius. Okay, in the presence of nickel, maintaining the temperature of 800 degrees Celsius to 900 degrees Celsius and maintaining a high pressure, that is 35 atmospheric pressure. Look at here, superheated steam. Steam is allowed to pass over where there is hydrocarbon at the lower area of this earth. Okay, so where the methane is present, when it is passed, it reacts and get converted into carbon monoxide and hydrogen. So the hydrogen can be obtained out. Another method is when this hot steam is passed over the coal, that is, or coke. It's a allotrope of carbon. So superheated or hot coke, it produces carbon monoxide and hydrogen. This carbon monoxide and hydrogen are called to be a syngas or water gas. Look at here, this two, that superheated steam is passed over the coke. Hot coke is present here, lower surface, and it get converted into carbon monoxide and hydrogen, which is called as the water gas or syngas. Okay, that syngas is collected up. That gas is used for the synthesis of organic compound, that is methanol can be prepared by using this, as well as some hydrocarbon can be synthesized in the laboratory by using a gas called to be a syngas or synthetic gas. So it is used to synthesize something, so we are calling it as a synthetic gas. Water gas shift reaction. Here the carbon monoxide of a water gas or syngas. Syngas is nothing but carbon monoxide plus hydrogen. To that mixture, steam is passed. When steam is passed at high temperature, that is 400 degrees Celsius, and in the presence of iron and copper as a catalyst in the over a shift converter. This is passed over shift converter. Carbon monoxide, hydrogen, along with that steam is passed. At the condition of this carbon monoxide is getting converted into the carbon dioxide. So the conversion of carbon monoxide of water gas into the carbon dioxide process is called as the water gas shift equilibrium. So the carbon dioxide formed in this above process is absorbed in the potassium carbonate solution. When it is treated with potassium carbonate solution, it gets converted into potassium bicarbonate.